Breaking news. At 0218 UTC this morning, a routine archival sweep triggered an alert inside the European Space Network's data vault in Darmstadt, Germany. The alert was not generated by a new object, but by old images. Images captured weeks ago. Images that, until now, no one had looked at closely enough. What astronomers noticed in the final confirmed frames of 3I Atlas was something no one was prepared to explain. Today, the impossible just happened, retroactively. Moments ago, observatories across 3 continents confirmed that the last images of 3I Atlas contain anomalies that were never flagged in real time. Anomalies that change everything we thought we knew about this interstellar visitor. If you want more verified cosmic updates as they unfold, make sure to hit like, subscribe, and stay with us, because this story is far from over. Within minutes of the alert, servers at NASA's Jet Propulsion Laboratory began pulling raw photon data from the Hubble Space Telescope. At the same time, engineers at ESA rerouted bandwidth to reprocess infrared frames from the James Webb Space Telescope. What they found was subtle but unmistakable. In its final observable hours, 3I Atlas was not behaving like a comet, an asteroid, or any natural interstellar body ever recorded. The last images do not show chaos or decay, they show precision, and that is what has shaken the scientific community to its core. Before we go any further, it's important to establish why these images matter and why the world's top institutions are now paying attention. 3I Atlas was tracked by NASA, ESA, and independent observatories from its initial detection by the Atlas Survey System in Hawaii. Follow-up observations came from the Atacama Large Millimeter Array in Chile, the Very Large Telescope in the Atacama Desert, radio arrays in South Africa, and optical observatories in Australia. Data was cross-validated at Harvard's Center for Astrophysics and Caltech's Infrared Processing and Analysis Center. Nothing about this object was casual. Every photon was logged, every trajectory modeled. And yet, the most important evidence remained hidden in plain sight until now. The final confirmed images of 3I Atlas were captured simultaneously by Hubble and JWST while the object was at a distance of 2.13 astronomical units from Earth, moving at approximately 41.6 kilometers per second relative to the Sun. At that point, it was already assumed to be exiting the inner solar system. Its brightness was fading. Interest was waning. The narrative was closing. Or so we thought. 48 hours before the last image, something subtle began to change. Spectral analysis showed a minor but statistically significant shift in reflected light, from a reddish carbon-rich signature to a flatter, more neutral spectrum. At the time, this was dismissed as rotational variance, but when reprocessed with higher temporal resolution, the shift followed a repeating pattern. Every 19.2 minutes, the spectrum changed, then returned. No natural tumbling object rotates with that level of precision without external torque. 11 hours later, a second anomaly appeared. Thermal readings from JWST indicated localized temperature increases of up to 37 Kelvin above background levels, confined to specific regions on the object's surface. These regions were not random. They formed a symmetrical distribution along the object's longitudinal axis. 6 hours before the last image, Atacama Array radio telescopes recorded a faint electromagnetic pulse in the 1.42 gigahertz band, the hydrogen line. The signal was weak, just above noise threshold, and lasted exactly 2.6 seconds. It repeated 11 minutes later, then again. Each pulse was separated by the same interval, with a timing precision of less than 0.01 seconds. No natural astrophysical process produces discrete, repeating emissions at that frequency from a body of this size and composition. 3 hours before the last image, the trajectory of 3I Atlas deviated by 0.0007 degrees. That may sound insignificant, but at interstellar velocities, such a deviation requires an impulse equivalent to several tons of force. No outgassing plume was observed, no debris cloud, no fragmentation. The object simply adjusted. This is where the last images become critical. The final frames show 3I Atlas against a dense star field, its outline sharper than expected for an object of its estimated size. When contrast enhanced, the silhouette reveals a geometry that is not smoothly irregular like an asteroid, but faceted, almost structured. Along its trailing edge, a faint distortion appears in the background stars. Not a blur, a distortion, as if space itself were being minutely perturbed. Dr. Elena Voskar, a computational astrophysicist at Leiden University, was among the first to notice it. At first, I thought it was a lensing artifact, but gravitational lensing at that scale would require a mass far greater than what we calculated. The numbers didn't match, so we ran the simulations again and again and again. At Caltech, Dr. Marcus Hobble's team ran gravitational models using every known mass loss scenario: sublimation, fragmentation, thermal cracking. None could reproduce the observed behavior. The object was shedding mass earlier in its trajectory, Hubble noted, but in the final images, the mass loss had stopped completely. The system stabilized. Meanwhile, at Harvard, Dr. Lian Zhao reanalyzed the radio pulses using machine learning filters designed to detect artificial modulation. The result was unsettling. The pulses were not random noise. They followed a mathematical pattern, specifically a sequence corresponding to prime intervals. Not encoded messages, but structured timing. At this point, two camps began to form. The mainstream explanation argues that 3I Atlas is an exotic natural object, a fragment of a disrupted exoplanetary body composed of ultra-dense material, possibly containing metallic hydrogen or unfamiliar allotropes of carbon. In this view, the pulses are plasma interactions, the trajectory shift a product of asymmetric thermal emission, the symmetry and illusion amplified by data processing. But the alternative interpretation refuses to go away. In internal memos leaked from ESA, one phrase appears repeatedly: controlled behavior. Not intelligence, not intent, but control. The object was not reacting, it was responding. Then came the second wave. 12 hours after the final image was taken, but before it was analyzed, Earth-based instruments began to register anomalies. Low Earth orbit satellites experienced brief communication dropouts. Amateur radio operators reported unexplained interference in the VHF band. Magnetometers in Scandinavia detected nanotesla-level fluctuations inconsistent with solar activity. Individually, these events meant nothing. Together, they formed a pattern that pointed backward toward the moment 3I Atlas vanished from view. When analysts aligned the timestamps, a chilling correlation emerged. The final radio pulse from 3I Atlas coincided within milliseconds of the onset of Earth's magnetic disturbance. Distance: over 300 million kilometers. Delay: none. This was no longer random, one internal report concluded. It was synchronized. Inside mission control rooms, the mood shifted. Conversations dropped to whispers. Data access became restricted. Requests for observation time were denied without explanation. At NASA headquarters, a closed-door meeting was convened with representatives from ESA, the Department of Defense, and several unnamed international partners. No press release followed. And then there was the image no one wanted to talk about. In the very last frame, captured at 0641 UTC, the object appears slightly elongated, not stretched or blurred, but extended, as if part of it were no longer fully present in our observable frame. The stars behind that region are not blocked, they are displaced. I remember staring at that frame on my screen, zooming in pixel by pixel, hoping to find a mundane explanation, a sensor glitch, a processing error, anything. But the data was clean, redundant, verified across instruments. For the first time in my career, I could not reconcile what I was seeing with any known law of physics. The global reaction has been muted, but intense. Governments have not issued statements, but emergency science briefings are underway. Aerospace agencies have redirected funding. SETI researchers have quietly reopened dormant protocols. And somewhere in a secure server farm, simulations are running, testing scenarios that were once considered purely hypothetical. As the noise fades, a quieter question remains. What if the last images of 3I Atlas were not showing us an ending,
but a transition. Maybe we're not witnessing the end of an object's journey. Maybe we're witnessing the moment it changed states, or purposes, or destinations. The universe has always spoken to us in the language of light and gravity. We assumed we understood the grammar, but now, confronted with something precise, controlled, and silent, we are forced to consider a humbling possibility that we are not the first to pass through here. The last images of 3I Atlas are not dramatic. There's no explosion, no farewell flare, just a quiet frame, and then nothing. And sometimes the most terrifying discoveries are not the ones that announce themselves, but the ones that slip away while we're still arguing about what they were. So the question remains, what did astronomers really see in the final images of 3I Atlas? And more importantly, why did it wait until the very end to show us? Subscribe to stay with us as this story develops, because whatever 3I Atlas was, the data suggests it is not done with us yet.